Okay, good. So today we will look at some measures that are typically used in classification, right? And so I will primarily focus on two class problems. Okay. The main reason is that more often than not, the classification problems we will encounter is for two classes. You know, want to identify it as belonging to a class or not belonging to a class, right? So multi-class classification is little rarer to come by, right? And frankly, two class classification has a lot more richer set of measures that people have proposed, and usually the ones that you use for multi-class classification are extensions of these measures to multi-class. Okay. So the first thing I want to introduce you to is something called the confusion matrix. Okay. So it is nothing to do with your understanding of the course material or anything so far. Okay, it is something completely different, right? So right. Okay. So I said it is a two class problem. Let us say the classes are 0 and 1, right. So I am going to say that, so I am going to form this matrix. So the true classes are on the rows, okay, the predicted classes are on the columns, right. I mean, it does not matter if you do the transpose of this, as long as you remember the meaning of the numbers that go in here. Okay. Okay, let us I am going to change this slightly. So I am going to call class, instead of calling them 0 and 1 as we have done so far. Okay. So I am going to call them positive and negative. So it makes it a little easier for me. So what is a positive class? Typically the class of interest to us, right. So what we will denote as positive class is the class of interest to us. What we denote as negative class is the class that we do not want, right. So when I say that in some problem that the positive class is that person is suffering from dengue, does not mean that dengue is something positive. Okay. Okay, it just means it is a class of interest to us. So just remember this. Okay. So when I say positive class, it is a class of interest. Okay. And more often than not, your positive class in the population will be small, right, hopefully, right. I mean, not too many of you have dengue, right. So the positive class will be small and the negative class will be large, right. So and you have to worry about getting the.
Does that mean people with dengue are interesting?
What does that mean? Of course yes, yeah. Of course yes. I mean that's my interest, right. So I am a doctor, I need patients to pay me, right. So obviously the people who are sick are more interesting to me than the people who are healthy, right. Right. So so that is a class of interest, and the negative class is the other class that I am not so much interested in, right. So things that go in here, right. So if the true class is positive, right, and I am also predicting it to be positive, okay, these things are called true positives, okay, otherwise known as, we will denote them as TP, right, they are true positives, okay. And what about these guys? They are true negatives, right. They are actually true class is negative and the predicted class is negative, they are true negatives, right. So that is why I said you just have to remember which is the true positive, which is the true negative and other things here. So whether you write it this way or whether you write the transpose, it does not matter, right, as long as you flip these two things around. So what about these guys? False, right. And what about these? So all of you know about true positive, false positive, everything, right. Everyone has been telling me all of this. So where have you encountered this before? Nowhere. Okay, so glaringly obvious. Okay, good. Great. So now, what is the most common classification thing that we know about? misclassification error, right, so, or accuracy, right. So 1 minus the misclassification error is known as accuracy, right. What will be the misclassification error here? Where n is the total number of data points, right. This is what? Misclassification. So what about accuracy? Huh? Yeah. So n is the total number of data points, okay, it is not the total number of negative points, in case somebody is worried about that, but I need a symbol for total number of negative points also, so I will introduce something later, right. This is known as accuracy, right. The accuracy, as you can see, is 1 minus misclassification error, right. And what are the other things that we know of that are very popular, right. So you can take a lot of different ratios of these numbers, right, and come up with different evaluation measures, right. So I will talk about a few popular ones. Does anyone know what precision is?
True positive plus false.
True positive?
True positive plus false.
So what does it mean? So the classifier is going to tell you so many data points are of the positive class, right. The classifier is telling you so many data points are of the positive class. How many of them are really positive, right. So the denominator is all those points which the classifier is telling you are positive, right. So true positives plus the false positives are all the points that the classifier tells you are positive, and the true positives are the ones that are truly positive, right. This ratio gives me the what is called the precision, right. So precision can be defined per class if you will, if you want to, right. So here I am doing this only for a 2 class thing, therefore we are talking about positives, but suppose I had a k class problem, I can treat it like a 2 class problem and I can give you the precision for any class. So suppose class, I am interested in some class k, okay, I will treat that as the positive class and everything else as the negative class, right, and now I can create a true positive, true negative. So I can actually talk about precision for class k, precision for class I, and so on and so forth. Again, for a multi class problem I can talk about precision, right, but typically it is defined for 2 class problems. So there is a complementary measure for precision known as recall, right. So what is recall? False negative. So what is recall? Essentially there are so many positive points in the data, right, there are so many positive points in the data. Of these positive points, what fraction is the classifier telling you are positive, right, you get that? All the positive points in the data, which is true positive plus false negative, right. So what fraction of it is the classifier telling you are positive? So that is recall, right. So one way of thinking about it is, so precision recall actually originate from information retrieval. They are not originally for the classification domain, they were originally proposed as a measures for evaluating information retrieval. So what do you mean by information retrieval? So there is some repository of documents, right, and then you type in a search query, right, and then I give you back results corresponding to that search query, right. Suppose there are 10 results that I give to you, right. Of these 10, how many are truly relevant to the query? What is that? Precision. Suppose there are 50 documents in my repository that are relevant to the query, how many of them appear in that 10? That is recall, right. So that is why it is called recall. So how many of them do I actually recall from the repository? So I have this huge repository of documents, how many of the truly relevant documents do I recall from the repository? So that is why it is called recall. And precision, you can see is actually a misnomer for people who are used to measurements, right. What is precision in measurements? Huh? Sorry? How? There is no notion of closeness in precision, right? No. Elect guys, come on. How many elect guys are still in the class? Huh? 2, 3, 5, 6, 7, 8. Okay, yeah. So what is precision? Sorry? How less the variance is? Precision is, if you go to measurements, right, precision is essentially how many digits you are going to actually measure it to, okay, that is precision. You did not be accurate, okay, accuracy tells you how correct you are, right. You can be less precise and very accurate, and you can be very precise and very inaccurate. I mean, I can give you absolutely random number to 10 decimal places, so I will be very precise, right, but I cannot make any guarantees about the accuracy, but precision here has nothing to do with that, okay. So precision here is essentially all to do with correctness, right. So if I am giving you 10 answers, how many of them are correct? So why is this a good measure? When is this a good measure? I already told you an example. Information retrieval, right. So what characterizes information retrieval? If you think about it, why can't I use accuracy in information retrieval as a measure? Why do I need something new, right? So why can't I use the following measure? Okay, I type in a query, I give you back 10 results, okay, that means of the remaining documents, okay, so I have rejected all of them, right. So these 10 documents I have classified as being relevant to your query, the remaining documents I have classified as non-relevant to your query. So among those I classified as relevant, how many are truly relevant? Among those I classified as not relevant, how many are truly not relevant, and I can do an accuracy, right. I can do misclassification error. So why is that not a good measure for information retrieval?
In the whole corpus there will be very few documents which will be relevant to this.
Yeah, so there will be just, like I said, 50 documents at best are relevant to your query, but you might have a 10 million document corpus. So if you are Google, you have several 100 billion documents as your corpus, right, and of which 10 or 15 might be relevant to your query, right. So if I just use accuracy as an evaluation measure, right, I need to be really precise in the measurement sense to make out any difference between two algorithms, because they mostly will be correct, because large fraction of the data I am going to say is irrelevant and I will be correct, right. Suppose I have 2 million documents and I am returning 10 to you, right, and there are only 50 things that are relevant. So basically I am right mostly, right, a few things I miss here and there, but I am correct most of the time, because I have said a large fraction of the irrelevant documents are truly irrelevant, right. So that way I am good, right. So that is not a good measure. So when there is extreme class imbalance, right, accuracy is not a good measure, right. If only 1% of your data is of positive class, then if I say everything is negative class, I am 99% accurate, but my precision will be what? You can define it to be 0, but mathematically it will be undefined, because I said everything is negative class, I have no true positive, no false positives, okay. So but you can define it to be 0 if you want, and recall will also be 0 in that case, okay. But quite often, so what you will find is that if you try to increase your precision, right, your recall will fall. If you try to increase your recall, your precision will fall, right. Why is that? So if you want to pull in more of the positive class, right, if you try to pull in more of the positive, if I want to predict, suppose there are 40 documents that are relevant and I want to predict all 40 of them as being relevant, see the easiest way to ensure that is predict everything as being relevant, right. So my recall will be very high, right, which will be 100%, right, but my precision will be too low, right, depends on what is my universe of documents, precision will be too low. So and if I want to have a very high precision, what do I do? Huh? Predict only the sure documents. Huh? Select no documents and then go back and define 0 by 0 as 1 instead of defining it as 0, right. So we defined 0 by 0 as 0 a minute ago, you can define it as 1, right, because undefined you can do whatever you want with it, right. So select no documents and say I am 100% precise, obviously because you can't point out a mistake I made in giving the documents back to you, right. So but then recall will suffer, right, recall will be 0, right. So there is always this trade off between precision and recall, right. So you have to figure out where you want to pitch your algorithm, right. So typically people draw what are known as PR curves, right, precision and recall curves, and so how do you think this PR curve should look like? Like this, like this, like that. Yeah, I mean you really want to be here, right, you want to have high precision and high recall, don't you? But then you can compare, when you compare algorithms you compare them against these PR curves, right. So for example, okay, let's go on, I'll tell you a little bit more as we get along, right. So there is another measure which is especially popular in medical literature called specificity. So what is specificity? It's something pretty different from what you have seen so far. It's what does it mean?
Inverse of the precision.
Yeah, so what does it mean? What is the semantics of this? The semantics of this is, if I say that something is, if I have a high sensitivity, if I have a high specificity, it means that if I say something is negative, then it is for truly, it's really negative, right. So why is this a good thing to have?
If you are saying that this patient doesn't have cancer, this is an
Really shouldn't have cancer.
Exactly, right. So this is very useful in medical tests. So I run a test, right, and I say that okay, you don't have malaria, right, or well, let's be topical, you don't have dengue, right, then you really shouldn't have dengue. It shouldn't be that okay, he said he doesn't have dengue, but then he really has, like there's a 50% chance you actually have dengue even though the test said you don't have dengue. Okay, that's a bad thing to have, right. So in such cases specificity is very important. So if you are building a classifier, right, that predicts whether a person is suffering from a particular disease or not, then it should have a high specificity, right. The flip side of specificity is right, which is this is a terminology that comes from the medical domain, right. So sensitivity is true positive by true positive plus false positive, and specificity is true negative by true negative plus false negative. Okay, it looks at the other things that you leave out here. Okay,
sensitivity.
this is specificity.
That's sensitivity.
The sensitivity. Yeah, there are two measures that you use, just like you have precision and recall in information retrieval. In the medical literature, you have sensitivity and specificity. Right, sensitivity is just like precision, while specificity is the opposite of that. Right, so sensitivity says, okay, how likely are you to? No, sensitivity should be recall. I think sensitivity is recall. Sorry. Yeah. Its sensitivity is recall. So it just says how likely are you to diagnose the disease. Right. If there are so many patients with this particular disease, how likely am I to find a patient with the disease? Right. So what fraction of the patients will I discover if I run this disease? Okay. So that's sensitivity, and specificity is essentially, if I tell you you don't have the disease, how likely is it that you don't have the disease? Okay. right. So, for regression we already looked at a classifier measure, more or less it is the same thing, right. So, you basically look at squared error, right. So, all the interesting things are all with classification, right. For regression you look at squared error, or you can do absolute error also. When you want to evaluate how good your regression fit is, you can do absolute error, you can do squared error as well, whatever it is that you use. So, there is one more thing which I want to talk to you about.